Hello students, in this lecture we are going to find out the eigenvalue again, but it is for 3 by 3 matrix. So let's write it like this. It is 3 by 3 matrix for which we are finding the eigenvalue. So let's take for example, we are going to find out the eigenvalues for the matrix A equal to 4, 6, 10. This is what the first row. Second row is 3, 10, 13. Third row is -2, -6 and -8. Now to get the obvious condition, that is A minus lambda I, its determinant must be equal to 0. Now for finding this A minus lambda I, when we obtain simply the lambda I, the I will be what? This time 1, 0, 0, 0, 1, 0, 0, 0, 1. This is simply the I, that is identity matrix of order 3 by 3. When we multiply this I by lambda, so this each term will be multiplied by lambda. So this will become lambda 0, 0, then 0, lambda 0, 0, 0, lambda. Now once I got this lambda I, then I will be able to find out A minus lambda I. So how to get A minus lambda I? So this is what A minus lambda I matrix. So we know A, that is 4, 6, 10. This is 3, 10, 13, -2, -6, -8, minus this will be lambda 0, 0, 0, lambda 0, 0, 0, lambda. So this is what the second matrix because of the result of lambda I, and this is our A, and this is nothing but lambda I. Now once we subtract this will result in some sort of matrix which is 4 minus lambda, then 6 will be as it is, 10 will be as it is. Only the affection will be to the lambda terms. So this will be 3, this will be 10 minus lambda, this will be 13, this is -2, -6, and this one is -8 minus lambda. So this is how we can get A minus lambda I. So let me write it here, A minus lambda I. Now I want to get the determinant for this particular matrix. So how to get the determinant? For this, I will just represent it like this. A minus lambda I, its determinant. We need to equate it with the 0, but before that let's solve it. So it will be like a term 4 minus lambda into this 10 minus lambda minus 6 into 13. This will be the value which we are multiplying. So -8 minus lambda minus this will become plus. So it will be 78. Similarly, when we multiply this second term -6 into the term that will be multiplied this time, it will be 3 into -8 minus lambda. So this 3 will be multiplied by this term minus plus. So this will become plus -2 into 13. So it will be 26. Similarly, the third term will be plus 10. Remember here the second term's sign, this must be the minus, negative. Plus 10 into, this time 3 will be multiplied by -6 minus, this -2 will be multiplied by 10 minus lambda. So things that are to be considered over here. So I will just solve it directly. This first term will give me the output, that is nothing but minus lambda cube plus 6 lambda square minus 6 lambda minus 8. If you just solve it, you get this first term. Similarly, the second term will give me the result, that is -12 plus 18 lambda. If you just solve this, you get this result of second term. This is the result of first term. Similarly, the last term will give 20 minus 20 lambda. This is what the last term. Now once we got this, then the only simplest target that we can just obtain over here, just add all these terms and get the value with certain equation in terms of the lambda. So this is what of the equation which we got. Now equate it directly to the 0 because of the condition determinant of a minus lambda I must be equal to 0. So we need to equate it to the 0. Once we have done this part, our task in our hand will be that we need to obtain the values of lambda. How to get the values of lambda? Let's simplify it here. So the equation we have, that is minus lambda cube plus 6 lambda square minus 8 lambda equal to 0. So let's change the sign for simplicity. It will be lambda cube minus 6 lambda square plus 8 lambda equal to 0. Now by taking the lambda common, it will become lambda into lambda square minus 6 lambda plus 8 equal to 0. So equate each term to the 0. So it will become lambda equal to 0. And the second is lambda square minus 6 lambda plus 8 equal to 0. This is what the first eigenvalue which we got. We need to obtain the other two from this equation which is given over here. So find out the quadratic equation's root. Means here we need to solve simply this quadratic equation. So lambda square minus 6 lambda plus 8, if we equate it to the 0, we will be able to just find out it like lambda square minus 4 lambda minus 2 lambda plus 8 equal to 0. So these are the two roots for it in short. So further by solving it, this will be lambda minus 4 minus 2 lambda minus 4 equal to 0. So lambda minus 2 into lambda minus 4 equal to 0. That is what the term becomes. If it is lambda minus 2 into lambda minus 4 equal to 0. So let's solve it further. So lambda equal to 2 and the second value will be lambda equal to 4. This is how we got the three values for lambda. First one is lambda equal to 0, second is lambda equal to 2 and third is lambda equal to 4. So these three are nothing but the eigen values for the given matrix. So that is nothing but simple method to get the eigen values. So thank you everyone. Thank you very much.